Uh, Good evening, all. We welcome you for this webinar by Institution of Naval Tactics on emerging trends in signature management of vibration and noise for marine systems. Today's presenter is Mr. Previous Ganesh Kumar, outstanding scientist NSTL. The chief guest is Professor Ramji of Andhra University, and the session chair is RAdm Retd, SP Shrivastava sir. It's my privilege to introduce the session chair, Admiral Shrivastava. He did his schooling in King George School, Mumbai, and Jain College, Mumbai. And after that, he did his graduation in mechanical engineering in NAT Surathkal. It was a 10-semester course during those times. And then he did his post-graduation in IIT Delhi on warship design and construction and got the best project medal. He has his post-graduation in submarine design from Naval Academy, University of St. Petersburg, Russia. And he is also having interpreter level qualification in Russian language, as well as certificate of proficiency in Spanish language. If you look at his career profile, immediately after graduating from NIT, for some time he was working in Batley Boy, Mumbai. And after that, he joined the Navy in 1985 in Marine Engineering branch and underwent a conversion to Naval Architecture at INS Vishwakarma. That was then called Shipwright School. Then he was posted at Naval Dockyard, Mumbai, and carried out his tenure there. And undertook all the repairs of all classes of submarines, both Russian and German origin. And later, he was deputed for the 3-year course in submarine design. Post-specialization, he was the assistant director in naval design in the Directorate of Naval Design Submarine Design Group. And all levels of functional responsibilities he undertook, and a wide gamut of disciplines such as structural design, hydrodynamics, habitability, system design, weapon and sensor integration, construction technology, design technology. He has worked in all these things. And on promotion to commander rank, he was appointed to head the Shipwright School. And there he was responsible for importing the training in naval architecture construction, as well as nuclear, biological, and chemical defense and damage control, NBCD. And the establishment conducted about 30 courses during his tenure. And then he was the manager, chief dockmaster, manager dry docks in Naval Dockyard, Mumbai. And then he went back to Submarine Design Group, and through various promotions, he became the Rear Admiral and Additional Director and Director General in the STG, and retired as Director General of the Submarine Design Group in 2019. After his retirement, now he is a DRDO Fellow. DRDO has observed him as a DRDO Fellow and is working in close collaboration with the DRDO laboratories, NSTL, NMRL, and NPOL, and also in prestigious projects. His wife, personal details, his wife is a voluntary social worker, and his hobbies are bridge, golf, and music and cooking. With this introduction of you, sir, I would request you to coordinate the sessions, chair the sessions, please.
Dr. Iyengar, thank you so much. Gives me great pleasure to moderate this session on a topic which I think is very, very meaningful and very important. And as we go along, I think we will all discover that today in warship design, and particularly for submarines, if we are looking for really answers in some field, it is in this field of noise suppression. So we all are going to look forward for this lecture. It gives me great pleasure to host Professor Ramji as a chief guest today. A few words about him. He's been the former Vice Chancellor of Ambedkar University and Nagarjuna University in Andhra. Currently, he is in the Department of Mechanical Engineering as a professor. He has not only he has a long list of qualifications with BE, ME in machine design and MTech in nanotechnology, but he has a very long list of achievements and awards to his credit. I would say that reading all of them and telling you all of it would take long, but just by the quantum and the quality of the work that has transpired under his guidance, 82 theses of masters and 45 PhD dissertations tells you the story in itself, that how well regarded he is as a professional. In his awards, he's been, I think, I would say perhaps, at least to my knowledge, I mean, 9 gold medals for various performances in academics, research, consultancy. He's been the best teacher in Andhra Pradesh, best engineer, also in Andhra Pradesh in the year 2010. He's been Dr. Radhakrishna Award in 2007. The best character, best researcher award again from Governor of Andhra Pradesh in 2006. Vijnana Pratibha Puraskar Award in 2006. The list goes on. So today, I think to have you, Professor Ramji, with us is indeed an honor, and we look forward both to your guidance and to your insight while you listen to the lecture and give us the benefit of your feedback. Once again, welcome Professor Ramji as a chief guest.
Thank you, sir. I am with you earlier in some of the projects.
Yes, we have done some of the projects together, HEAUV and others, and it's always been my good fortune to be in your distinguished company.
Thank you.
This lecture that we are going to hear today by Shri PVS Ganesh Kumar is a very well chosen one, and he's been a leading figure in this area of noise and vibration. Again, he's somebody with whom I have worked also for a very long time, almost for the maybe last 10-15 years, and off on various issues while I was in the submarine design group. He is an accomplished professional, has a very deep insight into this subject. His professional standing is, I think, not only well known to most people in the DRDO, but beyond the DRDO portals as well. He's been the recipient of the Agni Award for Self-Reliance in 2004, C.V. Raman Award for Acoustical from the Acoustical Society of India, the Titanium Medal by SA2RM, then now Secretary, but then SA2RM in 2009. He was the DRDO scientist in 2016, an award which is not given lightly and given entirely on merit, and very few. And I think it is one of the most prestigious, I would say, awards for a scientist in DRDO to receive. He's also had been commended for his distinguished services by the Acoustical Society in 2019. And he also is a recipient of Dr. Ramamurthy Award by the Condition Monitoring Society in India. He has a couple of patents on propeller noise and a water mist system for infrared suppression. While he's been a member of many committees, boards, etc., his valuable contributions are, I think, well known to all of us, and we will very surely reap the benefit of his experience when he speaks to us about this very important and intricate subject. Not many people understand the nuances of the subject. Importance everybody knows, and one of the reasons why we have not got to the bottom of this problem is because the nuances of the subject are not fully understood in the scientific community and in the industry. And that is why today, if we are struggling in one area, it is this noise and vibration. So thank you, Mr. Ganesh Kumar, for choosing this very, very apt and appropriate subject. And we all look forward to receiving an in-depth rendering on this subject from you. Mr. Ganesh Kumar, over to you.
Thank you very much, Shrivastava. It was nice hearing from you after a long time, actually. Recently, we are not interacted, but as you said earlier, we had a lot of interaction on various forums. And I thank Dr. Manu Kurula for, first of all, inviting me on behalf of INA when he talked to me about a week back. I said, okay, fine, let me try this signal, because this is one of the topics which probably is quite interesting to most of the people in the marine industry. They would be definitely interested to know certain parts of how we control vibration noise in a ship or a submarine. So I thought this would be an apt topic. I immediately agreed with him. But now I feel Institute of Naval Architects, being one of the leading forum in the naval architecture, whether I don't know whether I'm very apt to talk about noise and vibration in this forum, but as you rightly said, probably it will be interesting to all of you who are in the marine industry. So I would like to, I will try to do justice to the topic by giving only a very broad coverage of how to do the vibration noise control and what are all the techniques that are available today, and what are upcoming techniques in this particular field, so that later one can adapt if required, and maybe more details can be discussed separately for anybody interested. So this is how I phrase my topic today, the lecture. Can I share the screen now?
You can share your screen, sir. You can share your screen, sir.
Yeah. Yeah. Is it clear? Is it visible? Is
Yes, sir.
the screen visible? Okay.
Yeah. Very much.
Right then. So I'll go ahead with the topic itself. This is the topic which I've chosen: emerging trends in the signature management of vibration noise for marine systems. Primarily because today, as Shrivastava said, any ship or submarine being built, particularly indigenously, we need to take care of for this particular aspect of what is known as signature management, also as a part of design. Even earlier, the thought process was slightly different, that we do design and then take care of various signatures emitted by the marine platforms. But today's thinking is totally different. The signature management itself has to be a part of the design rather than a retrospective effort. So because of this change in the philosophy itself, the topic has gained a lot of importance. In fact, the signature management, in other words, we call it as naval stealth here. We can say the aim of this particular stealth technology is to protect our marine platform from detection by adversaries, to avert threat from air as well as from the other whichever side the threat is there, from both bombs as well as missiles, and the threat to hull from underwater weapons as well, like torpedoes, sea mines, etc. At the same time, we should enhance our own capability, the first strike capability of our platform. So stealth technologies in a way caters for both the defensive as well as offensive capabilities of the platform. You can see on the left side we have a non-stealth ship, which is a very conventional construction, whereas the right side shows a very only geometric figure of many people now know that Indian Navy has built one of the stealthier ships called P-17 class, and this is a typical image of that particular stealth ship. So, but though there is much more improvement now in the current scenario, with more and more stealth ships coming up. So in general, when we say stealth technology, we are only saying a military tactic basically, so that we are trying to conceal our presence from the enemy. So how do we do that? Is by what is known as the signature management. In other words, when we say whoever is able to have the first look will be able to have the first shot, and therefore will be able to first kill. So this is the principle on which this signature management works. That means if you're able to manage signature very well for the ships and submarines, you will be able to do the first look and first shot and first kill, and that is the aim of the entire signature management. And here I put two words called Trojan horse and chameleon. Probably many of you have heard about the Trojan horse, which is an example from the Troy War, where the Greeks built a big Trojan horse in which soldiers were held inside, and they kept the Trojan horse outside the Troy fort. And then Troy thought the Greeks have left the fort, and they celebrated as if they got the victory and took the Trojan horse inside their city. And suddenly from the Trojan horse in the night, the Greek soldiers came out of Trojan horse and invaded the complete city. So this shows this is an example of how stealth can function. It's basically a stealthy operation. The Trojan horse is a classical example of a stealthy operation where the soldiers were concealed inside a horse and deceived the Troys in the war. And this is basically means the stealth is something which you are trying to conceal your presence from the enemy and then try to attack him with a surprise element. The chameleon, of course, obviously everybody knows, chameleon is kind of an, it changes its color as according to the environment, and therefore we also have to build the whatever platforms in the war, whether it's ship or a tank or anything, aircraft, etc., to suit the environment in which it moves. For example, when a ship is moving in a sea or a submarine is moving in a sea, particularly for a ship, it is more applicable because an electro-optics point of view, optical point of view, and the visible point of view, if you are able to change the color of the ship in such a way that it merges with the sea, and then it is like as if there is no optical signature clearly seen, or visible signature is not clear. And so that is what is the example of the chameleon says. That means, in other words, what we are trying to say in principle here is that we are basically saying we are trying to hide ourselves from the enemy and then attack with a surprise element. And therefore, stealth, in other words, we are enhancing both the hard kill characteristics. That means enemy is destroyed before it can launch weapon. The soft kill characteristics, where enemy seeker will have difficulty in discriminating the target from the decoy. So, having heard the general philosophy of what is stealth, we look at the spectrum of signatures which we have to control for a typical naval platform like ship. Here you can see there are multiple signatures that we have to do. For example, you are talking of infrared signature, talking of radar cross section, you are talking of laser cross section, you are talking of acoustic airborne noise, underwater noise, magnetics, underwater electric field, or electrically extremely low frequency emissions, hydrodynamic wake, and these are the various signatures which we have to conceal or manage in such a way that these signatures, when they are emitted from the platform, are not visible or not seen by not sensed by the sensors of enemy weapons or enemy target, enemy vessels. Now, coming to this particular topic today, though I have shown a lot of spectrum, if I go back, you can see again that the previous one. You can see a lot of spectra here, a lot of signatures here. Out of all these signatures, as Admiral Shrivastava mentioned, that acoustics is one area where a lot of emphasis is now made that we should suppress the noise and vibration of the platform to ensure that the sonars and mines do not detect our platform. It's a very, very critical signature per se, and therefore this gets a lot of importance in how to ensure this particular control, acoustic noise control or underwater noise control. How do you manage? It depends on a lot of techniques that we have to develop. So that is the focus of this particular lecture today. So in general, we are talking more about how to control the vibration noise in a marine platform. So when we are talking of noise and vibration to be controlled, we have a concept called source path receiver concept. This is the starting point, for example, in the noise control. When I say source path receiver concept, source is basically for example, an engine on a ship is a source. It generates vibration. It transmits the vibration through its surrounding structure, and then through the hull it transmits as noise in the sea. So therefore, the source here we can say is typically a diesel engine or a gas turbine or any such auxiliary engines, etc. So many engines on board the ship become a source of vibration and noise. Similarly, a propeller is a source because propeller itself, when it churns, it generates a lot of both vibration as well as noise. And in a similar way, there is another source called flow also. When the ship moves in a water, all around the ship, you have the turbulence which is generated due to the movement, and that generates what is known as turbulent boundary layer noise. And this flow noise also can be sensed by the sensors from a distance. Therefore, flow noise also is one of the components. So like this, there are various sources on board platform or a marine platform, and you need to control all these noises. So for that, best would be if you are able to control this at the source itself. But is it possible always to control the noise at the source itself or vibration at the source itself? Probably the answer will be no, because one of the reasons why it cannot be done is once the design of an engine is already completed and installed on board a ship or a platform, it would be virtually impossible to change the design, and therefore it is very, very difficult to change any component inside the diesel engine. Therefore, the source modification per se becomes very, very tough unless you attempt this at the very design stage of the source, that is engine itself. So ideally, it should design a low noise engine or a low vibration engine at the design stage itself, and realize the engine before when it is installed on board ship. If the low noise is achieved, that is the ideal way of doing it. So therefore, source control is at the factory level. That means wherever the engine is being fabricated, before that it is being designed. So you have to design and fabricate in such a way that source is itself realized in such a way that it is low noise or low vibration. That is the ideal way of doing it. But then due to practical limitations, because of the standardization and things like that, there are many occasions where we find that in practice, the engines are standard engines are selected and they come on board, and therefore it will be almost impossible for us to modify a source itself. Therefore, the practical approach, what is being followed in most of the time to control noise and vibration, is known as path treatment. The second one, when you talk of source, path, receiver, the source itself is difficult to control because of various practical reasons, but path itself is what is controlled to reduce the vibration noise. So the path here, for example, in the case where I mentioned about diesel engine and its foundation and hull, etc., the path is nothing but the foundation structure and the hull itself before emanating into the sea as a noise. Therefore, if the path can be treated in some way to reduce the vibration and noise, then you will be able to achieve the required isolation of or reduction of noise. So this is the practical approach what we normally adopt, and there are many techniques by which this path treatment can be done, and this is being practically attempted in almost all the installations. And the third one is receiver. Receiver, of course, is something again may not be in your control, because, for example, in the case of underwater radiated noise that is going into the sea, obviously sea is such an infinite medium. It will be virtually impossible for you to control the sea medium. Therefore, it will be it's practically not possible. In a similar way, when we are talking of a noise being heard in the sonar compartment, sonar being a receiver from the engines that they transmit to even sonar compartment, there, of course, to some extent, the receiver treatment can be done into the sonar housing, etc. But otherwise, if it is an infinite medium, a typical receiver cannot be treated much. Therefore, what I am trying to say here, when you're talking of source path receiver concept, the path is something which you have to now focus practically when you're talking of noise control aspect. And when we are talking of this path treatment, there are typically two ways of controlling any such practical installation. One is called passive control method, the other is called active control method. And the passive control method is basically a method wherein you are trying to insert some kind of what we call an acoustic impedance in the path. mismatch, actually, acoustic impedance mismatch we are trying to create by introducing some kind of impedance changing element. The changing element could be typically, for example, for an engine, it could be a kind of vibration isolator, a mount, rubber mount, because the rubber mount is such a flexible body compared to the rigid engine or rigid foundation structure. So between two hard structures, when you are placing a softer material, obviously it will create an impedance mismatch. And that impedance mismatch is what you have to design properly to ensure the required vibration or noise suppression. This is typically a passive approach. Of course, whether it is a rubber isolator or some other kind of treatment that you apply, like damping treatments and so on, the principle is more or less, to control what is known as the impedance, either mechanical impedance or the acoustic impedance, based on the application of structure-borne noise or airborne noise, what we talked of. On the other hand, the other approach is active control. The active control is something which is relatively more modern method, but then the practical installations are very, very low because of the complexity in realizing the active control. Basically, what is active control? Active control here basically is a very simple concept. As a concept, it's very simple to say. For example, when you have a vibration spectrum, if you are able to create exactly the opposite signal, that means what we call as anti-signal, that is of the same amplitude, but completely out of phase. If you are able to create such a spectrum, which is exactly nullifying the original spectrum, then you are making the resultant signal as good as zero, almost nullifying the original spectrum. So to say this becomes much easier, but then to implement is a very, very complex thing in active control because of the way the complexity of the spectrum is generated. It is not a single frequency tone or something which are trying to control here. Actually, it's a broad spectrum generated vibrations from the engine. Therefore, if you are trying to control the complete spectrum using active control, you need a lot of iterative approach to do this. And also in a open environment, it becomes that much more complex in the realizing active control. We'll come back to that as we progress. And there is another aspect which has improved the noise control reduction approach today, is nothing but the computational techniques that are available today. The advent of computational techniques have really made the life much easier in terms of what we know as predicting the noise and vibration. And similarly, verifying whether our treatment is properly done or not by checking in a numerical approach. So both ways, it is really very, very useful, and it is much more comfortable to model and estimate the vibration noise today than the analytical techniques that are very complex, which could be very difficult to implement. But today, with the availability of this computational software, it becomes that much easier to model and analyze, and then come out with results on whether the predicted value is correct or not, or whether the modeling, whether the damping is working or not, what kind of treatment is working better. So this kind of relative studies can be done easily by using these computational techniques. And to add to that, we have the verification method of what is known as noise ranging, which also plays an important role, because finally, after implementing all these treatments on the ship and submarine, are they really giving the required noise reduction or not, can be known only by measuring the entire underwater radiated noise using what is known as noise ranging technique, wherein we lay a set of hydrophones at sea, and then run the ship over the array of hydrophones and see whether whatever recorded noise is well within the limits of what is expected, or if it is not in the expected limits, what to do can be planned. So in other words, we have when you sum up this particular slide, the noise reduction approach basically we have most practical approaches to do the path treatment, wherein you apply kind of vibration isolation or vibration damping or some kind of acoustic barrier, etc. All of them are typically like, most of them are passive controls which are practically implemented. But when it comes to active control, though some realizations are being done today, it is still far off from the maturity level what we really need to be practically implementable in ships and submarines. And the third aspect, which is which also I mentioned here, is computational techniques. The numerical techniques that have evolved over years has really made the prediction that much more easier, and also the verification of whatever treatment that you have done on board by using a numerical technique before the actual implementation also has become easier. And finally, the verification, exact validation as to what kind of noise is finally emanating out of the constructed ship is possible due to this noise ranging approach. So with this slide, I thought I have one question here from one of the attendees.
We can
Shall I
take the
ask?
question. We can take the questions at the end of the talks.
Okay, fine. So then I'll proceed with the next slide. Yeah. Yeah, these are various ship kiting technologies, which are basically implemented practically in many installations. Though it is not a exhaustive list, I'd say it is more of a representative list of various techniques that are available to reduce the vibration noise on board marine platforms. Some are internal to hull, some are external to hull. Internal to hull are typically, like I just said initially, if you are able to suppress at the source level is the ideal thing. That is where the low noise machinery is always the priority. If we are not able to do the low noise machinery, then we have to come to the other aspects like applied damping, for example, the constrained layer damping or Maastricht's what is known as free layer damping, and vibration isolation systems. Nowadays, of course, we are using even two-stage mounting systems and raft mountings, which are more advanced than a single-stage vibration isolation, which is conventionally used. And we have the structural modifications that are possible, like for example, a foundation can be modified to create more impedance mismatch. And typically, material changes also. For example, instead of metal, if you are using composites, the damping is much better in some of the applications. We have adopted this also. And flexible velos and compensators for piping, silencers and mufflers for intakes and exhausts of various engines, whether it's turbines or diesel engines. And we have acoustic enclosures, hoods and barriers to suppress the airborne noise, and detuners, which are basically like we can suppress what are known as tonal vibrations or tonal noise components by using what are known as detuners. Various forms of detuners are available. For example, we can talk of tuned mass dampers or tuned viscous dampers and so on. And similarly, external to hull also, we have various treatments, low noise propellers, bubble screens and masker systems, which are basically prairie systems, which some of the naval personnel are fully aware of, which basically masker systems, they used to give a kind of bubble formation to suppress the flow. And compliant coatings, again, a very useful technique for reducing the flow noise. Hull linings and decouplers are again useful in what is known as either you in the form of anechoic coatings or decoupling coatings, you can realize the hull linings, particularly submarines, it becomes that much more important. You can see the thick rubber linings given to the submarines to reduce what is known as echo from the sonars. And similarly, decouplers basically reduce the vibration that is transmitted as a noise to the other outside of the submarine. These are some of the representative techniques. Now, coming to the next slide, I would rather tell you that, as I mentioned in the beginning itself, that any signature management effort, if it is retrospective, it is not going to be the best. definitely it will be ideal if you are able to implement this at the design stage itself. So therefore, it is that much more important that you realize that signature management should be an integral part of the overall design spiral. And coming to only acoustic design spiral, this I call it as acoustic design spiral, where from the conceptual design stage of the platform, you start with your own prediction model of the acoustic or noise model, and then compare with noise limiting curves. If you are satisfied, you go ahead to the preliminary design level, and then again you would estimate the noise levels. And probably here at this stage, you may need to do some model experiments to correlate with whatever your estimations are done, and then analyze and evaluate those data from estimations and model experiments. And if required, you modify and refine the design and complete your preliminary design of for the acoustic part. Then you go to the detailed design part, where here you need to identify what are the quieter technologies. Like I listed some of the quieter technologies in the previous slide. What are those quieter technologies that needed to be implemented in the current design platform, that you can decide at the detailed design stage. Because by the preliminary design stage, you know where are we with respect to noise, and where are the possible lacuna or deficiency. From there, what kind of treatment is required can be arrived at, and accordingly you identify the required quieter technologies in the detailed design stage, and you interface the design with the actual design of the CAD/CAM of the platform, and generate the information for the planning and manufacturing part, so that it becomes integral with the actual design of the platform itself. And then in the construction phase, you have to now there is a stage where you realize the actual hardware. So acoustic hardware is realized, whatever noise techniques that you have identified have to be implemented. And then when you complete the implementation, you measure the ship on the shipboard, the noise measurements, analyze again and evaluate if required, slight refinements here and there, probably you have to do there. And then come to the final test and evaluation phase, where you have to hand over the technology transfer to the shipyard or the crew to maintain this various acoustic designed areas also. And then you do the final acoustic measurement, and if you perform a kind of uncertainty analysis, and any minor design deviation that you find, you have to add on and finally give the full scale reality to the user. So this is what we call as acoustic design spiral. Ideally, this is how a typical acoustic design for signature management should be done at the ship design stage itself. This is what we have been advocating to the designers always. Now, coming to various kinds of technologies or systems that are possible to implement in vibration noise control, we have vibration isolation systems, as I already mentioned, which is basically a kind of rubber isolator or spring isolators. Various forms of isolators are possible, and they give a lot of improved vibration isolation in the from the engine to the hull. It reduces the vibration, and then naturally it lowers the radiated noise signature. And here various forms of isolations are possible. You call it as two-stage mounting systems today, because instead of single-stage vibration isolator, you put two stages of isolators with an intermediate mass. We call it as two-stage isolation systems. And similarly, we have raft mounting systems and things like that. So I'll come to that in details in the next slide. Surface damping treatment is another approach where again you can have different kinds of damping applied to the hull and structures. This will reduce the vibration transmission, particularly in the resonance zones. And there are various treatments which are developed. For example, we call it a free layer damping treatment and a constrained layer damping treatment. And similarly, we have for airborne noise reduction, we have acoustic enclosures, hoods, silencers, and so on. And they basically reduce the airborne excitations and improves the habitability on board the ship. And in addition, we also have composite products which can give higher material damping compared to metals, and at the same time being lightweight are preferred, and they will be more maintenance free, and therefore slowly and gradually more and more composite products are being preferred on board also. And in addition, we have the supplementary, or we can say complementary tool of signature prediction, as I mentioned already, the computational techniques, which are also very, very useful at the design stage to estimate what we call a priori estimate of the noise at the new design stage itself. Various techniques are available in the numerical techniques. For example, finite element analysis is possible, boundary element analysis is possible, and high frequency we have covered known as statistical energy analysis. And, it is a topic by itself. But what I would say, like to say here is signature prediction today is very much feasible with the available tools that are there in the market in form of FEBA SCA software, like a typical example being VA1, Vibroacoustics 1 software, which is available in the market. You can easily implement, or you can simulate entire engine along with the mounts, etc., and check what is the kind of vibration and noise that is being generated by the engines and the hull, etc. So the models are possible to be generated very fast and can be estimated. So I'll just go through some of the what we call vibration isolation controls and noise control systems, which are typically being used in the contemporary stealth platforms. For example, two-stage mounting system is one of the very popular approach, which is used to reduce the vibration to a high level of dB levels. For example, if you are getting say 15 dB reduction, 15 decibel reduction with a single stage vibration isolation, you will be able to achieve almost 25 to 30 dB reduction with the help of a two-stage vibration system. It is not just because the doubling the isolation; it is about the way it is designed. You can see here. There are two stages of vibration isolators. One isolator here, another isolator here, and there is a intermediate structure, which is a metallic structure. So it is like where this intermediate mass, what we call, also plays a very critical role, other than these two stages of isolators, in determining the overall performance of the two-stage vibration isolation system. In addition, of course, because it is increasing the height of the installation, we need to take care of the roll and the pitch, and therefore there are some things called limiters which are placed on both sides to ensure that it doesn't sway too much because of the increased height. So we call it as limiters. So these are actually have been already tried and successfully applied by us on board ship, and it is being adopted now in almost all newer platforms, all new design platforms. And similar is the case with the constrained layer and free layer damping treatments, another approach where you can reduce the vibrations by adding what is known as viscoelastic material. The viscoelastic material, typically what we use is are various types of rubbers, whether it is butyl rubber or neoprene or nitrile rubber and so on. Various kinds of rubbers are available based on the environmental requirements as well as the performance. We have to choose appropriate materials. NMRL being our own sister lab, we take a lot of help from them in choosing the appropriate composition and identify the material. And then we test them at the laboratory by using our own, methods in say floating bars or a foundation structure. For example, this is a foundation structure. This is a floating barge in which we applied say a typical mastic treatment and tested for the vibration noise. So there are various viscoelastic materials tried, and we came out with various compositions, and even partial coverage is possible to reduce the weight penalty to ensure that we get the vibration isolation to the level of satisfaction. So this is another successful technique being implemented in various installations on board marine platforms for vibration noise reduction. And of course, here is another example of what is known as airborne noise reduction method, acoustic enclosure or a hood, wherein you enclose the complete engine or with what is known as barriers. The barrier materials are made of perforated panels with one solid panel outside and the perforated panel inside, and in between it is filled with what is known as the sound absorbing material. The sound absorbing material could be a kind of glass wool could be a mineral wool or rock wool and so on. There are various types of materials we have evaluated and found a different, based on the requirement of performance for different frequencies, we can tune the kind of material and accordingly to make a panel out of that. And these panels can be assembled to make what is known as acoustic enclosure. And so similarly, for smaller equipment, we call it as acoustic hood. You can see one here. This is a typical acoustic hood for one of the pumps, whereas this is a complete enclosure for a diesel alternator. And so typically we can design all of them at a very design stage of the engine room itself, so that the space constraint, whatever we have with respect to applications, will not be a problem in the actual implementation. So in the newer designs, we are having creating enough space to at the design stage, so that these enclosures, the hoods, etc., can be catered for in the design. For example, walk-in type design enclosure is a very, very important design for a gas turbine, and these are already being implemented. And another application where you can see is airborne noise reduction is silencer. Here we call it a dissipative silencer. Dissipative silencer, because silencers are various types of silencers available in the literature, whether we call it as reactive silencers or dissipative silencers and so on. Typically, what you see in automotives is a reactive silencer. It depends more on the geometric changes in the construction. Whereas in a dissipative silencer, we look at the principle of what is known as baffled silencing. Baffled means basically baffles are again made of panels which filled with wool, and these baffles are made of again a casing material, typically GI material, galvanized iron. In case you don't want any kind of maintenance issues, you can even use FRP composites also for the casings, and then again fill it up with the typical wool. And the thickness of the baffles, etc., have to be designed in such a way that we get the efficiency in terms of sound reduction. At the same time, it should actually allow the kind of mass flow that is required for the intake or exhaust. And these are successfully implemented and are being used in all ships and various marine platforms. And another thing I said is about the composites for vibration noise reduction, where you use fiber reinforced plastic for control of the vibration noise. Here you can see some of the examples. One typical foundation structure or a blower casing is fully made of FRP, or even a pipe. Composite pipes are made of made in onboard some of the ships. One of the ships we have actually implemented. Similarly, even a complete shafting can be made of composite shaft. So these are some of the typical examples where the inherent properties of the composite, that is primarily damping property of the inherent property of composites, can be made use of in reducing the vibrations and noise on a typical marine platform. And therefore, there are various possible applications for this. And some of the applications we could practically demonstrate. A nice prediction, as I already mentioned, the FEA, BEA, and SEA, the finite element, wound element, or statistical analysis combined with CFD will really provide excellent tools for noise prediction today. And there even commercially off-the-shelf software, COT software is also now available to predict the noise. Of course, they're very suitable at the design stage itself, so that you can play with the parameters to check what would be the ideal way of treating the platform for reducing the underwater noise. And therefore, it is being used now in our newer designs always. And this is typically some of the plots showing how a complete submarine or a ship can be modeled, and noise can be estimated for the complete platform. And of course, some more advanced technologies are being tried out all over the world, include some of the listed topics here. For example, the HTS motors, podded propulsors, composite propellers, advanced materials. Of course, there are various types of materials being tied to our material labs. MR dampers mounts, which of course partly we have realized already through what is NP oil, Cochin. Active control techniques, of course, as I told you, it's at a relatively preliminary stage of realization, but a lot of work is going on across the world in active control. And there is another important technique that is coming up for measurement or vulnerability assessment, acoustic vulnerability assessment, is the holography technique, acoustic holography technique, which is a very important technique for today to assess the vulnerability of a platform from noise point of view. Even an engine can be assessed for its noise pattern. It's a advantage being here you can get a 3D image of the complete noise pattern of the whatever object that you are doing the measurement. So it becomes that much more easier to identify the hotspot, and so that you can effectively control the source of noise. So this is becoming very critical technique now. Coming quickly on to the various topics that I listed just in the previous slide. A HTS motor is which is nothing but a high temperature superconducting motor. The high temperature is slightly misnomer actually. The high temperature in terms of cryogenics, it is called high temperature because compared to liquid nitrogen, the helium gas based superconducting motors are working at slightly higher temperature compared to liquid nitrogen. Instead of minus 77, they work at the 25 degrees Kelvin. So that is why they're called higher temperature. They are basically the advantage with this kind of propulsion or HTS motor is a big reduction in noise signature. At the same time, the size will be much smaller compared to conventional motors, and electrical performance is extremely fantastic. In turn, almost 98% is what is the literature says. And you can see the relative sizes you can see here. This is conventionally, say 36.5 megawatt is typically like this. For the same thing, it will become almost 1/4 in a HTS motor. So this is a big attraction. One is the size, and the other is lower noise and weight reduction, as well as the inherently quieter machine with the high efficiency. All kinds of advantages that it offers is really the major attraction in this. But then it's still in a what I would say only we could go to a level where we could technically demonstrate the high technology high temperature superconducting motor for a limited capacity of like in terms of kilowatt. To graduate to a higher capacity through of course we are working through BHL. It may take some more time, but then the effort is on right now. And similarly, the podded propulsor is another area where probably one can see the improved performances, particularly with respect to lower noise, because it's a directly coupled to the propeller. I mean, it's a direct coupling to the propeller. There is no gearing, etc., and therefore it's a motor directly coupled, and reduced bearing requirement, and it results in decreased vibration and also propulsion efficiency. It is another attraction. But then the podded propulsors have a limitation in terms of shock characterizing, and we need to graduate to a level where it can withstand the kind of shocks that are encountered in a typical naval scenario. Coming to composite propellers, of course, they are realizable. We have already done this for some of our applications. The composite, obviously, I said they are increased damping, at the same time lesser weight penalty. Obviously, maintenance will be much easier because there is no corrosion in this. There is improved, and they are shock and fatigue resistant, and they are well proven now. You see the typical metal versus FRP noise level curves here. You can see FRP is showing much lower noise level, particularly from medium to high frequencies. And these are two typical composite propellers realized in our laboratory for a typical application. And there are other materials, as I said, honeycomb, sandwich panels, which are also being tried by various laboratories, because these are now going to be used for hull construction also in future, and they are going to be highly noise reducing structures. And tiles I already talked of, like anechoic tiles and decoupling tiles, which are already being done by NMRL and for various applications, including submarines. But ideally, I would like to have anechoic and decoupling tile together in one tile, what is known as magic tile, a combination tile, where you try to meet the requirement of reduction of noise also from the platform. At the same time, try to reduce the echo coming from the outside sonar. So if you are able to achieve both the objectives in one tile, then that would be a wonderful tile. This is where we are now trying to lead NMR to develop. Whereas individually, yes, independently, both the kinds of tiles are already developed and proven. And so we are looking forward to the magic tile for the future. And they reduce the self noise, and they also are helpful in reducing the radiated noise signature. And I already talked of tuned noise dampers, though it is realized to some extent, further work is required, because we have to optimize the way it is being developed. The detuners can be one of the approaches, tuned noise damper. Here the idea is to reduce the tonal vibration that is coming from any particular engine or a pump or some kind of auxiliary equipment also. So if any particular equipment is giving a typical a single frequency tone as a dominant tone, then ideally this kind of tuned mass damper or a tuned viscous damper can help in reducing the tonal vibration. And you can see the typical reduction that you get. Without the TMD, you got this much peak, whereas when it is implemented, it has almost become flat. So this is a very, very effective tool or technique for reducing the tonal vibrations. Therefore, at the same time, it can be easily retrofitted also. That is one of the advantages with tuned mass damper, because it is fitted to the foundation, and therefore it is not going to affect the other construction of the engine, etc. So it can be attached to the existing structure. That is a major advantage of tuned mass damper. But it is only primarily for reducing what is known as tonal vibrations. And talking of MR dampers or mounts, magnetorheological, when you say MR magnetorheological, it's basically is a kind of concept where you are trying to suspend some kind of magnetic particle, like tiny iron particles, in a carrier liquid, what is known as typically mineral oil, wherein this particular thing, when it is implemented as a damper, the viscous properties of it gets changed rapidly due to the vibrations impinging on them, and thereby giving a signal which can be controlled to reduce the primary vibration. So this is based on the what is known as feedback circuit. In a typical active control combination also is there here. It is not just a passive method here. It's basically a combination of passive and active, and therefore we call it as a semi-active technique. It was already implemented in one of the realizations, and gradually it is being improved towards ruggedization to ensure that it can be implemented on actual platforms with a much easier way than the current way of implementing. But as a technique, it is already being proved that it provides very good low frequency control of the vibration and noise. So far, whatever passive techniques I talked of, most of them are very, very effective at the medium to high frequency. When you're talking of MR mounts and things like that, they're basically active control, for example. They are very, very suitable for low frequency control. In fact, one of the areas where nowadays a lot of questions keep coming to me is to how to control the low frequency vibration. This is one of the ways to do that. Of course, active control, I already talked of active control. Here it's basically working on the principle of destructive interference. Basically, when a primary signal is there, you are trying to create a secondary signal in such a way it nullifies the primary signal, and that's why it's called destructive interference or a principle of superimposition. And so we are basically generating an anti-signal, and you are trying to suppress the primary vibration or noise. So, but then in implementation, it becomes very, very complex because it involves a sensor with a feedback controller and an actuator to generate the secondary control. And this is a big paraphernalia that you have to set up to control the low frequency vibration or noise. And so sometimes it becomes very cumbersome. Second thing is it becomes complex because it is not just a single tone that you are trying to control. You are trying to control multiple frequencies simultaneously. So it becomes that much more difficult to generate an algorithm to generate a secondary control algorithm. So that is why it is now a very strong research area where many people are working on how to improve active controls in various installations. I think if I have some more time, I'll just run through the remaining 2-3 slides and I'll conclude. Amir, can I continue?
Yeah, sir. We have time. You can go.
Okay, fine, right. So I'd like to conclude fast. Basically, we are now having the other methods like so far I talked of only the methods to control and things like that. I also talked about the predictions, etc. And there is a testing method also that is required always at the laboratory. And these are some of the test facilities that are required to do the testing whenever you develop certain material or certain technique. You need to test them at the laboratory, and acoustic test facilities are some of them which can be used. For example, anechoic and reverberation chambers that are available at NSTL can be used to test various materials or various techniques that are developed for their efficacy. So this is typically one of the examples. And similarly, when we are talking about vibration, again we need some test facilities to check for example, the mount, whether the vibration isolator is giving required performance or not. You can easily check by using putting it on a vibration shaker and with a required mass on the mounts, and then check for its performance, how much vibration isolation actually it is giving typically, or what is the dynamic deflection it is giving, what is its dynamic stiffness, and many other parameters can be checked using what are known as vibration test facilities, which we have even at NSTL also. And there is another technique sometimes being used on board or field situations where we suppose I need to know what is the natural frequency of a particular component of vibration natural frequency. I can use what is known as modal testing, which means basically you're trying to extract the natural modes of an object. There are various methods by which modal testing can be done. One is the previous slide I showed, the vibration exciter. The modal excitators can be used. Other method is the picture which is showing here, a person hitting with an impact hammer. So one can hit with the impact hammer, which is instrumented. It has a force transducer. It has a displacement sensor. So it acquires the force as well as displacement on the object, and then extract what is known as transfer function, which we call it typically frequency response function. And that from the frequency response function, you can extract what are known as the natural frequencies and the mode shapes of an object. So this is another approach which is practically used to extract the frequencies from the practical structures. And in addition to this, as I mentioned already in the first slide, that we have a requirement of a range to really know what is actually the noise being generated by a typical marine platform, for which we need a kind of sensor array along with the acquisition systems, data acquisition systems, to acquire the data and then analyze the data to know what is the kind of noise spectrum that is being generated. There are various ways of doing this. One is a permanent range setup, which we typically in a sea, it's some of the depths we can generate. We can have a range permanently set up, wherein sensors can be laid on the seabed and then the connected through a fiber optic cable to the shore, wherein we can acquire the data. This is a typical setup which can be used for permanent range setup. On the other hand, we have also a provision to do the portable range setup, like you can carry a portable range instrumentation for certain depths. Up to certain depths, you can measure this. And deep noise ranging, for example, a submarine, if you want to measure the noise, probably both these permanent range setup or portable range setup may not be feasible to do easily. Whereas we have mobile range setup, mobile acoustic range setup, what we call MARS setup, which can be used which can be deployed to measure a submarine noise at a very deep depth also. For example, 150 meters depth also, you can measure what is the submarine noise. So there are various approaches which have to be used based on the application. If it is ship noise, probably permanent range or a portable range can be used. But for a submarine at a diving, I mean, if it is a shallow depth, it's okay. You can do it typical range setup. But when you're talking of depths of 100 plus, etc., you have to go for a mobile range setup. So finally, today we are talking of assessing the acoustic vulnerability priori, for which again we need latest techniques like acoustic holography, which can measure the radiant noise using what is known as holography technique, wherein you are basically putting a lot of sensors all around the object and then acquiring the sound intensity, and integrating them into a kind of image map, which can be generated all around the object. What is the noise actually being spreading from the object towards the outer periphery, and therefore you get to know what is the typical noise envelope of the platform. So from that you can easily gaze at what range of the ship can be detected by an adversary, a sonar. So this is a very, very useful tool. And of course, obviously, it would be ideal if you have a onboard ship itself a noise monitoring system, online measurement of vibration noise by placing various sensors on board itself at critical locations for assessing its vulnerability by getting the data through the sensors onto a particular data ecosystem in a control room, and then seeing on the control room itself what is happening to the ship vibration noise at a nutshell, and it will be much easier. Put a kind of a green, yellow, red kind of a system where even the operator can see whether vibration noise is well within the control as of now. If there is any alarm, he will immediately alert the at least higher ups to look into the details. So this typical noise monitoring system also could be quite useful, and I think some of the ships already have got this. So with this brief on what are the today's vibration noise techniques as well as upcoming techniques in the marine platforms, I just want to say, to master the noise and vibration technologies, definitely we need to have techniques to predict noise radiation. We should also be in a position to identify the major sources at the design stage itself, and accordingly attempt or design the quieter technologies relevant for those controlling those major sources. So the development of those vibration noise control techniques becomes that important for that. And then finally assess what is the vulnerability by using a kind of even numerical holography techniques. Acoustic vulnerability assessment can be done after implementing all this. As I shown in one of the slides in the design spiral, if you follow those design spiral technique at each stage, probably assessment of acoustic vulnerability becomes that much more practicable. And by doing all this, you will be able to do the signature management from the noise and vibration aspect with very, very effectively. And you should of course always look at the changing requirements as per the scenario, in the world scenario, the state of the art requirements, and accordingly overall tactical signature management has to be attempted. We cannot be fixed on what is to be followed at any particular time. You need to adapt yourself to keep improving your techniques to ensure that you are on par or slightly better than what is being tried out by others. So this is what is being tried as Admiral Shrivastava mentioned in the beginning, with Dr. Bhujangarao giving initial push for us. We started working in that area from those days onwards, and we have come to a stage where we can confidently say that we have all the noise and vibration control techniques that are possible elsewhere are definitely available even with India, and therefore we will be definitely improving much further, and will be definitely ensuring state of the art is there with our designs compared to the world. So with these words, I'd like to conclude, and I should thank the organizers for giving me an opportunity to share my thoughts on noise and vibration control applied to marine platforms. These are some of the typical references that I've used. You can see even Bhujangra's paper I have listed here. In fact, the design spiral, whatever I put it, is basically from this paper. And Baranek and Ware, of course, is a very popular book on noise vibration control engineering. And Harrison Paisel is one of the best books on shock and vibration side. And therefore, we always refer to these books as a kind of a Bible. And of course, there are many other reports that we have generated over the years. I have referred in the slides. Of course, I didn't put that as a reference, but then there are many technical reports which were generated by NSTL. Because of the classified nature, I didn't put the most of the results, etc. I only put the techniques, but I have not put the actual results to avoid no sharing any classified data. With this, I'd like to thank once again the organizers for giving me an opportunity to share my thoughts on this particular topic. Thank you very much. Can I go ahead with the question and answer session?
Well contained and comprehensive overview of what is the state of the art today, both in the country and I think generally globally. We can do one thing. We can take on the questions first, and then maybe a little more discussion. There are some things maybe I could also add.
Yeah, sure.
With your permission.
Yes, no, definitely. Well, not. Why not?
Or maybe I'll just still speak about those things so that maybe there's some questions can emanate from that also, perhaps.
Sure.
There was one question which seems to have gone off from the question answer box. That
Yes,
was about the hull-induced vibrations affecting machinery. I think that was the intent of the question. That is how I understood it.
Okay.
I think you had mentioned already that.
Yeah.
One is, I think, just for the participant who was asking that question. You may like to answer that.
Yeah.
In your paper, it was there. I mean, in your presentation, it was there about vibration resistance. But I think perhaps we could clarify that. One thing I wanted to just ask your opinion is how well is our Indian industry geared to delivering the quality of equipment that we are looking for, noise and vibration. Because we have spoken, I mean, you spoke very well about the platform level this thing. But the source of the noise is the equipment.
Yes. I agree.
Perhaps there are some challenges here.
Yeah, I share your concern for the kind of equipment that are being delivered. I do agree that we have not matured. Industry is not matured enough to say if you are trying to compare with say GE turbine and what Indian manufacturers can produce. Definitely, we are not on par. Our industry is not on par. Definitely.
It's a food for thought that.
Yes, definitely. It's a.
Industry doesn't have anybody to turn to. The industry does not know who to ask for advice.
Yes. Agree. I fully agree. That is a requirement. Yes, we need to meet as a country. But then you see they are also evolving slowly and gradually, and I'm sure probably in future years they will also come up with some of the best quality products. In fact, already we are seeing some of the pumps and all are very high quality we are getting on par with this state of the art. Probably as we grow the engines also we may have to get right now even automotive engines we are not making properly in India. They are being imported. At least design part of it. The design is not fully made here. So engine, yes, I fully agree that we are not definitely on par. Not only industry, even the design part of it. As far as engineering, not only manufacture part of it. I'm talking of even the design of the engines. We are not on par at the moment. Yes, definitely not. We need to improve a lot on that. But apart from that, because the source is already having certain limitation, we can only overcome by doing what I said is about the treatments that we adopt in the path, whether it is isolators or whether we are talking of damping treatments or whatever. If we are able to adopt the best of the techniques that are available today, still we will be able to overcome that deficiency as of today, as on today. So that is what I am trying to bring out.
I agree. Thank you. Perhaps you'd like to take on the questions. Shall I read them out?
Yeah,
Or
sure.
you see them?
I am seeing two questions here
Yeah.
on the screen. One is, I think it's a long.
No, excuse me, sir.
Yeah.
Sir, excuse
Okay.
me.
Yeah, sure. Yeah.
Just a minute. See, normally what we do for the questions asked, we
Yeah.
request the questioner to
Okay.
come on,
Fine,
come
fine.
alive and then ask the question.
Agreed. That's nice.
Yeah.
It can be
So,
done.
Amir,
Sure.
can you please request Mr. Chug and Dr. Shinoy, Professor Shinoy, to come?
Sure, sir. Yeah. So I've requested Professor Shinoy, and I'll also add Mr. Naresh as well. Right after that. Professor Shinoy, are you able to share your screen, speak and share your screen? Yeah. Thank you.
Can you hear me now?
Oh, yes, we can.
So first of all, compliments to the speaker. I mean, it was a fantastic lecture, very clear, easy to understand on a topic that is so comprehensive and so wide. So for people like me who are uninitiated in many of the details, I think I learned quite a lot. So thank you very much for your excellent talk. I have two questions. One relating to sources of vibration and their control internally, inside hearts, and the second relating to vibration from external sources. On the internal, you mentioned MR, liquid, so magnetorheological liquid, which is fine for low frequencies and so on. I wonder whether you have any thoughts on the MRE, so magnetorheological elastomers, and whether you have any views and opinions on that and what your experiences are. So that's one question. The second question relates to propeller-borne noise. Clearly, there will be compromises needing to be made between hydrodynamic efficiency on the one side and noise suppression on the other. And again, I wonder what your thoughts are in that regard. So open questions, but I greatly value your thoughts. Thank you.
Right, thank you. Nice questions indeed, actually. One question you asked is about the MRE, that is magnetorheological elastomeric material. Actually, whatever product that I have shown in the slide is a combination of elastomeric and magnetorheological, in fact. Because the advantage that we get by combining elastomeric with magnetorheology is that you get both the, I mean, it's a kind of hybrid that you get. You get an advantage of both passive as well as active control. That is why we prefer to have elastomeric combined with magnetorheological material, and then you get both the high frequency or medium and high frequency as well as low frequency with the MR. So a combination of MR and E gives a kind of hybrid advantage, that you get the very what we say wide frequency suppression of vibration, and therefore that is most preferable, and that is what is actually realized by us. So I hope you're able to understand that part, that it is not just low frequency. It is about, while doing low frequency control with MR, we also, by adapting the elastomeric part in a combination with that, we are able to do medium and high frequency control also, and thereby we are getting both the passive and active control together. So that's why we call it as a semi-active or hybrid control approach. Am I clear to you, Dr. Shinoy?
Yes, thank you. Thank you.
Right. And as far as second part is concerned, yes, you rightly pointed out, when we are talking of propeller noise reduction, we always face this dichotomy of how to match the hydrodynamic requirements and at the same time reduce the noise. They are actually having certain contradictory requirements, and therefore it has to be a carefully balanced exercise that we have to do. And so we don't just go for design for noise alone. In fact, when we do actually design for noise, we always check for what are the implications of this noise reduction of the propeller on hydrodynamic parameters, whether it is thrust or power. What is we again calculate back what would be the implication on the thrust and propulsive performance. And if the propulsive performance is not compromised, then only we take that noise suppression technique as a valid one. Otherwise, we don't take that noise suppression technique at all. Even though independently that noise suppression technique may be wonderful, but if it is not satisfying the hydrodynamic parameters, being the primary requirement, we will not compromise on that. So we always ensure that the hydrodynamic performance is definitely catered for while doing the low noise propeller design. Am I clear?
Yes, thank you very much. Thank you.
Yeah, right. Thank you.
Ganesh, perhaps that last question, which is there now on the box.
Yeah.
One more has come in now.
Okay. Yeah. Yeah. Second person, Naresh Chug, I think. If you can come online, you can answer.
My question is simple. I'm asking about the noise suppression or noise reduction materials like dampers, insulation, perforated sheets. Then we talk about pumps and machinery, generators. Are these available in India?
Okay. If you can mute, I think I'll just answer this. Yeah.
Mr. If you can mute it. Thank you.
Yeah, thank you. Mr. Chug, actually, it's when you are asking about materials like whatever I said about polymers or sound absorbing materials like wools, etc., or perforation sheets, GI materials or composite materials. Yes, very much they are all available in India. But when you're talking of pumps, engines, etc., they're slightly of different category. They're equipment. And when you're talking of equipment, again, we have progressed quite well in India on agri equipment to a large extent. But then when you're talking of prime movers like turbines or diesel engines, etc., definitely we are not on par at the moment. Some of them we are still importing. But when you're talking of noise suppression materials alone, definitely they are all available within India. Whether it is sound absorbing material, whether it is polymers, or any other vibration noise suppressed material that we are trying to adapt in our designs, including even magnetoreological fluids, whatever I talked of, they're all available in India and they're all made in India only. So I'm sure there will not be any difficulty in sourcing them in our area, our applications. Only the equipment side, yes, we have still some kind of a deficiency in terms of prime movers. Is it okay, Chug, or do you want further elaboration on this?
Yes. Thank you very much.
Right.
Yes. One more question from Mr. Soma about the passive active vibration controllers, which are better in case of TMD.
Can Gautam Chari come online? What exactly do you want to know? It's not clear for me.
Yes, sir. Am I audible?
Yeah, sure. Yeah, please tell me.
Yes, sir. You discussed about noise controllers, vibration noise controllers in terms of by using TMDs. But come to the TMD cases, we are having active controllers and passive controllers. Which one are you going to use for the vibration controller in the case of ships?
Yeah, right. I understood what you're trying to ask. Basically, you're trying to say which is a approach that we passive or active, which is used in TMD. Tuned mass damper per se is basically passive technique because it only implies basically kind of a combination of spring and mass with a little bit of damping added to that. So it is like any spring mass damper system that we encounter in vibrations, but only thing it is tuned to a particular frequency. When you're talking of tuning to a particular frequency, it basically means you are already having a kind a frequency which is disturbing the or giving a high tonal vibration at a particular frequency. It's giving a very high peak. So So you want to reduce that particular peak of the tonal vibration. You have to actually tune the damper to suit that same frequency. That means the natural frequency of whatever tuned mass damper you are generating should actually match the disturbing frequency which is being generated by machine. So, for example, if a particular machine is generating, say, a very high tone at a 25 hertz, 25 cycles per second, then you have to also have a tuned mass damper having a natural frequency of 25 hertz natural frequency. So, accordingly, you have to design a damper or tuned mass damper to have a spring as well as mass to suit that root K by M matching the 25 hertz. You know that natural frequency is nothing but root over K by M, where K is stiffness and M is mass. Therefore, you have to select in such a way that K and M of that particular tuned mass damper are such that the root over K by M is equivalent to the disturbing frequency, that 25 hertz. As long as you are able to do that, your tuned mass damper will work. But that again you have to be careful in practical installations, because the sizing becomes very, very critical there. Therefore, you have to be very careful choosing the appropriate spring material and the appropriate mass material. So that is where the crux lies. The basic principle remains same of identifying spring and mass to tune to the required frequency, but then the selection of our design of that materials is what matters a lot in the tuned mass damper. But basically, it's a passive technique; it's not active technique.
Yes, sir. Thank you.
Okay.
Sir, previously you discussed about the reduction of radiation vibration also. Sir, here I would like to highlight one more thing here. Based upon the choosing of the hull shape also, mostly what is that, mostly affecting the radiation vibrations. So here, what kind of hull shapes are you using so that which will give the less radiation vibration in our country of ships? May I know, sir?
Okay, so I'll try to understand your question. Basically, you're trying to say whether the shape of the hull is going to play a role in the vibration reduction, first of all.
Yes.
And if it is so, how do we modify that to suit the required reduction? That's what you're trying to ask.
Yes.
Yeah, but then normally, typically the hull once it is designed, it is not easy to change the shape and all. Therefore, normally we don't attempt that. Instead, what I told is the treatment on the path. Like for example, the damping on the hull. You can apply a free layer damping, for example, on a hull. And then you know what is the hull thickness, etc. And therefore, based on the hull thickness and the hull material, you have to design the suitable damping treatment to ensure that the thickness of the damping treatment gives you enough performance of vibration reduction. And that is what one of the slides I mentioned about what is known as the mastic, for example. The mastic is nothing but a kind of a thick viscous putty made of, it's basically rubber composition, but it is made in the form of a putty. It can be directly painted or applied on the hull to the required thickness, and it will reduce the vibration to a large extent on the hull. Therefore, that is one of the say effective techniques. But for that, you need to put enough required thickness on the hull of the damping. So that thickness determination is what is the design there. How much thickness determination is required, plus what are the properties of the damper. That when I say properties, it is basically the loss factor of that particular material, and also the density of that particular material. They play a lot of role in the performance.
Okay. Thank you, sir.
Okay.
Thank you, Mr. Ganesh. I think we have maybe a few minutes more.
Yeah.
In the answered box,
Yes,
there are
yes.
two questions by Mr. Tripathi. I think you covered more or less, you have covered them in the presentation, but perhaps you can give a quick response to that.
Okay, sure.
Good evening, sir. Radharaman Tripathi. I just want to know what are the codes, design codes are available for designing the shipboard equipments? Like, because those shipboard equipments are subjected to various types of vibration, maybe shock loading, random loading, and sinusoidal loading.
Yeah.
And that may be related to waves and related to equipment and any shock which is coming. So do we have any design code or something code? Because I have heard about the testing code, one mil standard 167 1A. But do we have any design code related to that?
Yeah, we can say yes, but then they are not openly available. That is one part. And second thing is, you see, there are various codes available with the standard bodies. Like for example, you have the IRS and LRS and things like that. For merchant ships, definitely they are determining the codes. But then when you are talking of warships and all, we have a different approach altogether, and therefore that is not openly available. But other than that, when we are talking of modeling a particular ship or something, there are various possible codes that software you can use. It's not actually a design code, but you can verify a design using the software. Like for example, you can. I talked about VA1. You can even use say hypermesh and other tools like shock analysis tools are available, like LS Dyna, etc. So there are various software that are available to verify the shock and vibration performance per se. But when you're talking of design code, it's a totally different approach. Design code is something which is generated out of a lot of what we can say study done, and a lot of database that is generated. Based on that, the design code is generated, and that is not normally openly available for a warship. For a merchant ship, yes, there are design codes available from the standard bodies.
Okay, thank you, sir. Thank you.
May I just come in here?
Mr. Ganesh,
If,
Kumar, I think before I we sum up, I would
just a second, sir. I'll just request Mr. Radharaman Tripathi. See, if you're talking about commercial ships, then there are two codes. The original code, IMO code, was IMO resolution, assembly resolution A468. That was published in 1982. And that has been updated and virtually completely, overhauled in MSC Resolution 331 in 2012. Both of them are available on the internet. You can have it from there.
That's right.
Thank you very much.
Okay, thank you, sir. Thank you, sir. Thank you.
Do we have time for more questions?
Yeah, one more question I'm seeing in the box, which is called answered, but then I don't know. There's an anonymous attendee is what he's asking. I don't know whether we should answer that or we can leave it.
That was Mr. Tripathi wanting to just now talk, sir. I think a couple more questions have now come, sir.
Perhaps you can take this one by Mr. Datta. It's an interesting one. What should be the frequency gap between the natural frequency of an object and its excitation frequency for an ocean-going as well as naval vessel? Yeah, probably.
Okay. Mr. Anudit Datta.
Yes, sir. Good evening, sir.
Yeah. Good evening.
Yes. So first of all, a very good evening to the all juries. So my question is, sir, what must be the frequency gap between the natural frequency and the excitation frequency for a ocean-going vessel as well as for a naval vessel?
Okay, that's an interesting question, actually.
I'm also adding the same thing.
Okay. That's very interesting, actually. So
narrowband and wideband. Most of the people are doing not a color noise.
Even if you're running short of time, it's worth looking at it.
That you can address that part.
Yeah. So that's a very good question. But basically, see, always your natural frequency, you always try to make sure that it is much farther away from any excitation frequency for a ship. When we say much farther away, and when you're talking of practically, if you are able to manage at least 2 to 3 times beyond, I think that then you are very safe. If you are not able to ensure that if you are within 1.5 to say 1.25, something like that, then you always have a chance of some time a kind of resonance that may occur. Therefore, always ideally you should keep it at least 2 to 3 times away, if possible. That is the best way to maintain the gap. Of course, more is better always, the gap. But then practically it may not be feasible. So at least 2 to 3 times. In many cases, I found that it is feasible.
But Ganesh Kumar, most of the people, they will test it model analysis, harmonic, transient, these are the things.
Yes.
But nobody will touch about random vibration, that is the color noise, excitation.
No, random vibration is something which is not very important in terms of slow-moving vehicles, particularly like, for example, ships and
especially ship on sea wave height every time changing.
No, that is not going to create so much of random vibration. Basically, the random vibration is very, very critical in terms of aircrafts and missiles because of the high speeds that they generate and the fluctuations that they generate in the turbulent bundle air. So the random vibrations, that is why you can see even the codes when you are talking of testing or vibration, etc. Normally they are not, for ships and all, they don't prescribe a random vibration code at all. They normally prescribe only sinusoidal testing or resonance search. Whereas when you're talking of aircrafts and missiles, etc., always you see random vibration is given a very high priority because of the nature of the vibrations that are generated there. Here in ships being slow moving vehicle, we don't get that high. No.
It is slow moving, but sea is sometimes rough conditions.
Yeah, that is right. But then that is not going. That is only flow induced vibration. It is not. It is not the primary source of vibration for us. In terms of ships, the primary source is always mainly the machinery and the propeller. And the flow induced noise or vibration are very, very relatively much lesser significance, unless the sea state is almost like 5 or something, 5 and above. So otherwise, it's not going to matter so much. That is why we don't give that priority to random vibration in the ships and submarines.
Okay.
Sir, we are not able to hear you, right? Now it is fine.
Yeah, now it's clear.
I think the earphones were. No. Before I sum up, I would like to invite our chief guest, Professor Ramji, to say a few words and give us his impressions of this lecture and the session today. Professor Ramji, please.
Okay. Good afternoon, everybody. First of all, the extempore lecture given by Ganesh Kumar Garu of his 40 years of experience has done related to vibration and noise. And he is, in that area, he selected today topic that is emerging trends in signature management and vibration and noise. See, not only ships or a propeller or any vehicle or even human being also. Nowadays, after COVID, a lot of health problems. There also, the doctors is managing with signature only, most of the time. So that signature management is one of the very, very important aspect in almost all fields of engineering or medicine, whatever may be the field. So in that direction, you touched upon almost all issues, whatever is there. And also, I am thanking the Institute of Naval Architecture for organizing this particular, and also they have already organized 7 technical sessions. I think monthly they are organizing one. Definitely it will benefit the entire society and the nation as well as in the global level. One thing which I want to request from this association is you tie up with other organizations like we have in Andhra University or in IIT Madras or IIT Chennai, IIT Kharagpur, Cochin University, NPL. There are some organizations. In Andhra University, we have Society of Naval Architecture and Marine Engineering. One S name is there. If you can tie up, because it is a free time, jovial time, 4:30 to 6 hours. So many participants may join. This is my one suggestion to the institution INA, because today participants wise may not be more number not benefited. For the benefit of the society, if you can invite more numbers, because this is extempore lecture, if it can listen by more number of people, definitely it will benefit. See, first of all, again, I thank today our good friend Manu sir, and we have in some of the meetings, Rear Admiral Shrivastava sir, Iyengar and Bharadwaj sir, for doing under their dynamic leadership, they are organizing these type of events. Definitely, if you can networking and collaborating with, in addition to your R&D part, some industry. As you know very well, the government of India is moving towards some of the new policies like Industry 4.0, Education 4.0, and National Education Policy. Mostly they are touching upon digital technology and automation. So this is one area where definitely it is useful tool and put in the curriculum of the syllabus, because they are the future engineers or scientists who are working in different organizations. Already their curriculum, but latest developments, whatever is there, if you can involve those people, I think you are extending for only members, but it can be open to others. Maybe a lot of people may be benefited. And as far as Ganesh Kumar sir, you touched upon most of the hardware part, software part, and experimental testing, like different dampers with active and passive, different systems like pumps, alternators, enclosures, propellers, and different materials. Definitely, I think a lot of people benefited with this lecture. And thanks for me, for the entire family of INA for inviting me as a chief guest for this particular event. Thank you very much, Shrivastava sir. This is from my side.
Thank you, Professor, for honoring us with your presence, and we are very grateful. To sum up, I think very quickly, I can do that. The presentation, I think, did full justice to the subject of noise suppression on board vessels. Siddharth Gupta had spoken about the IMO standards. Yes, they are relevant, but the case of warships and submarines are a little more challenging. It goes way beyond what IMO demands. That definitely is a subset of what is required. As we said, I think the challenges have also been very, very clearly brought out, as also what the future tells, for what future holds for us, and some of the new technologies which are emerging. I think Mr. Ganesh Kumar had brought it out and put them in the right perspective. I'm very glad that the question answer session also yielded a deeper insight which went beyond the presentation and probed some of the areas that one needs to know and understand when we deal with it. We all hope these kind of interactions, and particularly on this subject, will happen more often, because to me personally, it's very close to my heart. Having been in the business that I was, it always pinches you when you feel that in the country the knowledge is there, but somehow we are not translating it meaningfully and successfully into suppressing signatures. The only other thing for all the participants is just like to point out that all that we do in terms of suppression, one must always keep an eye on what is being done for detection. Ultimately, what means somebody adopts for detecting us, detecting you, should also dictate which areas of technology you must visit. So this is a bit of a cat and mouse game, but this must continue. And while we get a grip on acoustics in the years to come, we may leave some other areas unexplored, and you could have surprises in terms of technological development that will lead to detection by other signatures. No, though it is not noise alone, but in general, even in noise, one must keep looking at the capability that is being built up by sonars, by air reconnaissance, patrol capabilities, etc., to be able to match them and supersede them. So noise suppression is not in itself. It is part of a bigger game. You need to outdo the enemy always. So keep an eye on. People generally forget to look at ASW technology. One must keep one very eye on the ASW technology and then decide what we need to do. Thank you very much, Mr. Ganesh, for this wonderful lecture. I thank Mr. Dasgupta, Dr. Iyengar, and the wonderful team at INA. This is one of the very few flawless webinars I've attended. Otherwise, generally, you get into some glitches or the other. I think this was very wonderful done. Thank you, Dr. Iyengar, for your effort and this thing. I would just request now Mr. Manu Kurula to deliver his vote of thanks.
Thank you.
Thank you, Shrivastava sir, for a wonderful summing up of the total events today, including the talk that we had. I hope I am audible.
Yes.
Yeah. I am really thankful to Ganesh Kumar sir on behalf of INA and all the stakeholders. I thank Ganesh Kumar sir profusely for giving a very comprehensive idea on the signature management. As Shrivastava sir said, today the signature was managed very well, so that we had a seamless session. Yeah. And this, the emerging trends, yes, this is one of the most important emerging trends as far as naval systems are concerned. It is important for Navy as well as it is important for other naval systems as well, because we have to keep the environment as such, as much silent as possible. Okay. I profusely thank Professor Ramji, who has been continuously there with us in all our endeavors. He, as a Vice Chancellor of the university, he has shown his capability. And even much before that, he had been associated with naval systems and materials. And many of the autonomous sea systems, he was actively associated with NSTL in developing. I profusely thank him on behalf of the INA, Institution of Naval Architects.
Thank you, sir.
Of course, Admiral Shrivastava sir, he had been always there. So he is an inside person. So I need not specially thank him. He is a person always inside. And I'm always requesting him.
He's your family person.
Yeah, we will be really happy to have him all through in the coming days as well. Now, of course, this lecture has been very, very well attended by the people who are there. They were very serious about this talk. And I thank Professor Shri, Professor Ajit Shri, and Mr. Naresh and others who brought in some interesting discussion and some queries for the today's talk. Of course, Dasgupta Saab again needs a real clap and appreciation for making all this happen. The comments made by the chief guest, Professor Ramji, that we'll be definitely taking up that in the coming days. All those people, they are a part of the system that Institution of Naval Architecture Students Association. They are also a part of this. I was told that they also attend some of the seminars today. So I think they are attending together. That is why they are shown as one. At Andhra University, those students are attending this. I hope. This is what I was told. I am sure the INA in the coming days, with the guidance and leadership of Dasgupta Sahab and others, will make a bigger team in the near future for attending this fabulous invited talk series. One person who is always acting behind is the Amir Ahmed, who has contacted, netted, and made all this possible. And the person who has made all these things happen is the technical secretary, Dr. Bharadwaj Srinivasan Iyengar. So I thank them all and wish them all the very best in all the future technical sessions. I am sure in the time when COVID was there, they have started this session. And someday, at least, we'll be able to meet each other face to face, and we'll have a grand INA lecture series or a conference in the near future. I would also request Ganesh Kumar sir, if he's still there, to announce about the conference the Institution of Engineers they are going to host at Vizag.
Yeah.
This is a conference. I request Ganesh Kumar sir just to mention about this. Then I'll complete.
Sure. Thank you, Manohar sir, and thank you, Shrivastava for your kind summing up. And Professor Ramji, he has always been, a good friend of me, and he has given me a lot of encouragement from university side. Whenever we did some work, he was always with us. And coming to the session today, I only focused on the very broad coverage because of the nature of the audience, and I didn't want to get into the mathematics and details of vibration equations and things like that, because that may bore the people. That is the reason why I put it more in a nutshell, so that it can be easily understood by audience. I hope that suited the persons who have attended from the questions that I can see that there is a general understanding of what was talked about. And about Srivastava's comments, signature management, definitely it has to be looked at an integrated way rather than look at only noise suppression or vibration suppression. Definitely, that is the most important aspect. It should be looked at an integrated way, and that is why the very third slide I showed about the various spectrum, Naval stealth spectrum. Whether you talk of magnetic signature, whether you talk of radar cross section or infrared signature, all of them have to be looked at in a holistic manner for a platform rather than individually suppressing any one particular signature. It has to be. That is why we call it as integrated signature management approach for any platform. I think once we are able to do that, then you will be successful to overcome the state of the art developments in the other side. He rightly brought out that it is a fight between the signature management and the sensor development on the other hand. There is a continuous improvement in sensor development also. So that war will go on between the sensing and the hiding. So we will try to keep up with the pace as per the requirement of the current scenarios always. So with these few words, I would like to thank once again all the organizers for particularly giving me this opportunity, and for the good participation of interactive session also. And now I would like to announce about the another convention that we are going to organize on marine. It's called National Marine Convention of Engineers, being organized combinedly by Institution of Engineers India and that is Vizag chapter, and our NSTL, the DRDO combination. So it is going to be organized during October 15th and 16th. 15th and 16th are the dates. Please mark them, and I request all of you to please spread. We will I will definitely share the brochure of the conference with Iyengar. He can circulate to all the INA members also, and I request Dasgupta ji also to support us in this endeavor by spreading it to the members as well as getting some good papers, if possible, from the members to participate in the conference. Yeah. And of course, the effort is to have some more invited talks also in the convention. It's a 2-day convention wherein we are trying to have at least about 6 invited speakers speaking about various contemporary developments in the marine technologies. And particularly in this particular conference, I think the focus, as Dr. Ramji was bringing out, one of the focus area will be Industry 4. So definitely that is going to be one of the focus areas. The theme and all those details will be given to you through the brochure, and various topics that are listed out for the convention will be brought out in that brochure. And the dates, of course, are very, very tight for us, because being in October, it's already we are almost coming to August. So we hardly have 2 months. So we are working out hard to match the dates. We have received some abstracts already, but we can extend the dates if required for receiving the papers. In case some people are interested to then send the papers, I will try to accommodate those papers. Contributed papers make the conference more interesting. Invited talks anyway are going to be there, but then I'm interested more in the contributed papers. Yeah, right. Please tell me, Dasgupta.
Just one question. Will it be entirely in physical mode, or will it be in hybrid mode?
We are right now thinking of.
We may have.
Yeah, right. Please go ahead. Please go ahead, sir.
If it is in hybrid mode, then we can invite some of the overseas, who are scientists and engineers who are a part of the INA. They can also contribute, from like Professor Shri is from UK, Southampton University. Then in Singapore and in US, we have a lot of people.
Agree.
So we can invite them also.
In fact, we are right now we are open. We are open to that idea, definitely. In fact, we have discussed this point also in the committee meeting, and we said let us keep it open to hybrid mode also, because mostly we prefer physical meeting, but then in case it will help us to conduct it in a better way, hybrid mode will not mind to have it. Definitely we'll have it hybrid mode also.
Okay.
So
thank you.
It can be made.
We'll spread the news.
Yes, right. Manu, are you there?
Yeah. Thank you very much, sir. That has been so nice of you.
Hybrid mode is one thing which you are not.
Yeah. We should consider hybrid mode, because we may get some, as Dasgupta ji said, we may get some international speakers and orators.
Yes. Absolutely.
Relevant orators. Yeah.
We can be definitely open to that. That is very, very good idea. We should have that. So anyway, more details will be shared, sir, through the brochure. I think I request Iyengar to circulate it to all the INA members also, and we will follow.
Thank you, Ganesh Kumar.
Thank you.
So that today's actually we should say that it has been very successful. Today's total program. India is progressing with the aircraft carriers INS Vikrant. Yesterday it was handed over to Navy, and there are many other orders coming to shipyards. So it's a very good situation that is coming up. I'm sure all of us will rise to the occasion, and INA also will be able to address some of the common interest questions and areas among the members. I once again thank Dasgupta ji and Bharadwaj Srinivas for giving me this opportunity. Actually, Vizag chapter, I have been asked to lead the Vizag chapter of INA. I am thankful for that, and we'll be doing our level best. Now the new format has come, how to apply and all the things. We'll be talking this information, we'll be spreading this information, and definitely will come up well. Thank you. Over to Bharadwaj.
Okay. Thank you so much, then.
Thank you, sir. Thank you, sir.
Wish you all the very best.
Conclude for the day. So thank you, sir.